That little bag of popcorn sitting in your kitchen cabinet right now. Somebody engineered every single millimeter of it. The kernels inside were grown to a specification that most farmers don't even know exists. They were sorted by machines that can reject a single bad kernel out of 10,000 in under a third of a millisecond. They were coated in oil that was chosen not for flavor, but for physics. And the bag they're sitting in, it's not a container. It's a cooking device. A precision-built, heat-generating, pressure-controlled cooking device that fits in your hand. We went inside the factory where this whole thing is built from scratch. And what we found completely changed how we think about something we've been eating our entire lives. The only corn that pops. Before anything happens in a factory, before any machine runs, before any bag gets made, the entire process depends on one very specific decision made long before the kernels ever arrive. The decision of which corn to grow. There are over 50,000 known varieties of corn in the world. Corn for flour, corn for feed, sweet corn for eating, decorative corn, and then, sitting entirely alone in its own category, popcorn corn, scientifically called Zea mays everta. It is the only variety on Earth with a hull strong enough and a moisture pocket dense enough to do what popcorn does. What makes this corn different isn't visible from the outside. A popcorn kernel looks similar to any other dried corn kernel. The difference is what's locked inside. A small amount of water, roughly 14% of the kernel's total weight, sealed under a pericarp so hard and so uniform that it can hold pressure the way a pressure cooker does. When heat hits that moisture, it converts to steam almost instantly. The pressure builds, the starch inside starts to soften, and then, at one specific moment, the hull gives way. The kernel doesn't crack open, it explodes outward. The soft starch inside inflates, solidifies in the air, and what was a hard 0.1 gram kernel becomes a light, airy piece of popcorn, roughly 40 to 50 times its original size. A popcorn kernel must reach an internal temperature of exactly 180 degrees Celsius before it pops. Below that, nothing happens. Above that, it scorches before the pressure builds. The entire expansion happens in approximately 135 milliseconds. That's less than the time it takes your eye to blink. This corn is grown almost exclusively in 6 states in the American Midwest: Indiana, Nebraska, Ohio, Illinois, Iowa, and Missouri. The soil, the climate, and the growing conditions in these regions produce kernels with the most consistent moisture content. Consistency is everything in this business. A kernel that's 1% too dry won't pop properly. A kernel that's 2% too wet will pop unevenly. The entire factory process downstream depends on getting that raw ingredient right before it ever reaches the loading dock. There are dozens of popcorn varieties: butterfly, mushroom, ladyfinger. Each pops into a completely different shape. Did you know popcorn shape was an engineered choice, not a natural one? Which shape do you prefer and why? Drop it below. The rejection machine. Kernels arrive at the factory in bulk tankers and grain trucks. A single delivery can be anywhere from 20,000 to 40,000 kilograms. Hundreds of thousands of individual kernels packed together. The moment they arrive, they don't go into production. They go into inspection. Because the factory's first job isn't to make anything. Its first job is to find everything that shouldn't be there and remove it. The first pass is mechanical, vibrating screens and gravity separators that sort kernels by weight and size. Anything too small falls through. Anything too large gets pulled aside. Rocks, clumps of soil, broken stem pieces. All of it is separated at this stage through pure physics. No cameras, no computers. Just precisely calibrated screens moving at a frequency that makes the right-sized kernel travel in one direction and everything else in another. Then comes the optical sorter. And this is where the factory starts to feel genuinely remarkable. Banks of high-speed cameras mounted above a fast-moving conveyor belt photograph every single kernel multiple times per second. Each image is analyzed in real time by software that checks color, shape, surface texture, and size simultaneously. A kernel with a dark spot, air jet fires, kernel gone. A kernel with an irregular shape that suggests internal cracking, gone. A kernel that's slightly off color, which can indicate fungal contamination or improper drying, gone. The whole rejection decision, from camera capture to air jet firing, takes less than 0.3 milliseconds. A single optical sorting machine in a popcorn factory processes up to 10 metric tons of kernels every hour while maintaining the ability to reject one individual defective kernel without disturbing the thousands around it. The air jet that fires to remove it is so precisely calibrated it affects only the target kernel. Nothing else on the belt moves. After optical sorting, the kernels go through moisture testing. Samples from each batch are pulled and tested in the quality lab. The target range is 13.5% to 14.5% moisture content, a window of exactly 1 percentage point. Kernels below 13.5% have lost too much of their internal water to generate enough steam to pop fully. They'll either not pop at all or produce a tiny, dense, chewy result. Kernels above 14.5% carry excess moisture that turns to steam too slowly and unevenly. You get partial pops, misshapen pieces, and a lot of unpopped kernels at the bottom of the bag. The moisture window isn't a preference, it's a requirement. Getting the kernel right is only half of what this factory does. The next stage, how they actually get flavor onto a raw kernel before it's ever popped, is something most people have never thought about. And the process is more precise than almost anything we've seen in a food factory. The flavor drum, how taste gets engineered. Once the kernels clear quality control, they move into the coating stage. This is where the factory starts building flavor. Not onto popped popcorn, but onto the raw kernel itself. The coating has to survive being sealed in a bag, stored on a shelf for months, and then survive the high heat of the microwave process before it can release its flavor. That's a very specific engineering challenge. The kernels go into a large rotating drum, a steel cylinder that tumbles continuously. As the kernels rotate inside, two things are added simultaneously through precisely controlled spray heads. First, oil. Then, riding on top of the oil as a carrier, the flavoring. The drum rotation guarantees that every kernel passes through the spray zone multiple times, building up an even, consistent coating across the entire surface. The drum runs for a set duration, timed to the second, and then the batch moves on. The oil is not applied by feel or by eye. It's applied by weight, measured by sensors in the drum system. Most microwave popcorn brands use coconut oil or palm oil specifically because both fats are solid at room temperature. This keeps the coating dry to the touch on raw kernels and prevents the kernels from clumping together in the bag during months of storage. When the bag heats up, the oil melts and activates, which is part of why the first 30 seconds of microwave popcorn smells the way it does. Now, the butter flavor question. It comes up constantly, and it deserves a real answer. Real butter is roughly 80% fat and 20% water and milk solids. Inside a sealed popcorn bag that might sit on a shelf for 6 to 9 months, real butter would go rancid within weeks. So factories use flavoring compounds, the most common historically being diacetyl, a molecule produced naturally during fermentation that gives butter its distinctive aroma. Most modern brands have switched to diacetyl alternatives following health concerns related to factory workers in the 2000s, but the chemistry principle is the same. A naturally derived flavor compound, stable enough to survive shelf storage, that releases its aroma when heated. When you open a bag and that smell hits you immediately, that's a molecule that was engineered to do exactly that, at exactly that moment. Knowing the butter flavor comes from an engineered fermentation compound rather than actual butter, does that change anything for you? Some people find it fascinating. Some find it unsettling. Where do you land? The kernel is sorted. The kernel is coded. But none of it matters if the bag isn't right. And what the bag actually does, what it's physically built to do, is the part of this process that most people find genuinely hard to believe. The bag is the machine. Pick up a microwave popcorn bag and bend it slightly in your hands. You'll feel it has structure. It's not floppy like a grocery bag. That's because it's not a bag in the conventional sense. It's a 3-layer laminate. The outer layer is paper, for printability and structural integrity. The inner layer is a food-safe film that's oil-resistant and heat-tolerant, because it's going to be in direct contact with hot oil and steam for 2 minutes. And in between those 2 layers is something most people have never heard of: a susceptor. A susceptor is a layer of metallized polyester film, so thin it's practically transparent, that has been treated to absorb microwave energy. Your microwave oven produces microwaves that excite water molecules and generate heat indirectly. The susceptor does something different. It directly converts microwave radiation into thermal heat, concentrated, intense, surface-level heat that can reach temperatures a standard microwave cavity never generates on its own. The susceptor doesn't just help the popcorn cook. It's doing a significant portion of the actual cooking. The bag isn't packaging that gets in the way of the process. The bag is part of the process. The susceptor layer in a microwave popcorn bag reaches surface temperatures of up to 230 degrees Celsius during cooking, roughly 30 degrees hotter than a standard home oven running at full heat. It's specifically engineered to reach that peak temperature and then taper off as the popcorn finishes cooking, which is why microwave popcorn doesn't continue cooking itself after you remove it from the microwave. The bags are manufactured on large roll-fed production lines. Massive rolls of the pre-laminated, pre-printed material feed into forming stations that fold, cut, and heat seal each bag in a continuous motion. Speed on these lines is measured in thousands of units per hour. Once the bags are formed, they move directly into the filling station, where automated heads drop a precisely weighed portion of coated kernels, typically between 85 and 100 grams depending on the product, into each open bag. Then, the final seal closes the bag completely. Every bag that comes off the line passes over a check weigher, a scale that reads the bag's weight in real time at full line speed. Underweight bag, rejected. Overweight bag, rejected. The tolerance is usually within plus or minus 3 grams. Then seal integrity testing. Sensors check every heat seal for gaps or weak points that would cause the bag to fail in the microwave. A bag that vents during cooking loses pressure, loses the susceptor effect, and produces dramatically inferior popcorn. Those bags don't leave the factory. The bag is doing as much work as your microwave. It's essentially a single-use cooking appliance built into the packaging. Did you know any of this before today? We're genuinely curious how many people have thought about this. Every bag you've ever bought cleared at least 5 automated quality checks before it reached the shelf. But there's one final test that happens in a room that smells exactly like what you'd expect, and it might be the most important check of all. The last test, plus what the numbers actually mean. At the end of every production run, a sample of finished bags gets pulled from the line and taken to the quality lab. And in the quality lab, they do something refreshingly simple. They pop them. Workers microwave sample bags, measure the expansion volume of the popped corn, count and weigh the unpopped kernels, evaluate the texture and color, and compare everything against the product standard. A batch that expands to the right volume but leaves too many unpopped kernels doesn't pass. A batch that looks right but has off-color pieces doesn't pass. The product standard exists in writing, but the final verification is someone standing in front of a microwave doing exactly what you do at home. Those unpopped kernels at the bottom of every bag are called old maids inside the popcorn industry. Kernels that had microscopic hull fractures, lost their internal moisture before reaching popping temperature, and were never able to build the pressure required to expand. Despite decades of engineering effort, no manufacturer has eliminated old maids entirely. They are, at this point, considered an accepted characteristic of the product rather than a defect to be solved. From the moment a bulk kernel delivery arrives at the factory gate to the moment a sealed, labeled, inspected bag is packed into a shipping case, the entire process runs in under 4 minutes per bag. A single production line, operating 24 hours a day, produces over 1 million finished bags. During that entire process, from receiving to shipping, no human hand touches the product directly. Every transfer, every coating, every seal, every weight check happens through automation. The humans in the facility are monitoring, adjusting, and testing. But the product itself moves from raw material to finished consumer good without any direct contact. A bag of popcorn, grown to a 1% moisture specification, sorted by cameras making decisions in 0.3 milliseconds, coated in a drum with oil chosen for its melting point, not its taste, sealed inside a bag built with a layer of film that converts microwave radiation into direct heat, checked 5 times before it ever leaves the building, and sitting in your kitchen cabinet right now, looking like the simplest thing in the world. Nothing is as simple as it looks, and that's exactly why this channel exists. If today changed how you see something you've held 100 times without thinking about it, subscribe to Infusion and Elements. We break down a new factory process every week. The next one is already filmed. We'll see you there.